NASA's James Webb Space Telescope has resolved a long-standing puzzle in planetary science, confirming a controversial discovery made by the Hubble Space Telescope more than 20 years ago. Current models of planet formation are called into question by the Webb telescope's observations, which have produced vital evidence that planet-forming disks existed in the early universe for a longer period of time than previously believed. The oldest planet in history was discovered by the Hubble Space Telescope in the early 2000s. It is 2.5 times larger than Jupiter and formed in the Milky Way 13 billion years ago, less than a billion years after the universe was created. Soon after, other ancient planets were discovered. Scientists were perplexed by this because stars in the early universe should have contained nearly none of the heavy elements that make up planets, such as carbon and iron, and instead mostly light elements like hydrogen and helium. According to astronomers, the star's radiation should have blown away the disks of gas and dust that surrounded these light element stars, dispersing the disk in a matter of millions of years and leaving nothing behind to form planets. Scientists believe that later supernova explosions produced the heavy elements required to form a durable planetary disk around a star. In order to unravel this mystery, scientists use the Webb telescope to study stars in the Small Magellanic Cloud, a nearby galaxy that resembles the early universe because it lacks heavy elements. The team examined the massive, star-forming cluster in GC 346 in this dwarf galaxy, a stellar nursery with a small number of heavier elements using Webb's exceptional sensitivity and resolution. Hubble's results from the mid-2000s, which indicated that planet-forming disks still encircled some stars in GC 346 at an age of 20 to 30 million years, much longer than the accepted 2 or 3 million years, were supported by Webb's observations. In order to unravel this mystery, scientists used the Webb telescope to study stars in the Small Magellanic Cloud, a nearby galaxy that resembles the early universe because it lacks heavy elements. The team examined the massive, star-forming cluster in GC 346 in this dwarf galaxy, a stellar nursery with a small number of heavier elements using Webb's exceptional sensitivity and resolution. Hubble's results from the mid-2000s, which indicated that planet-forming disks still encircled some stars in GC 346 at an age of 20 to 30 million years, much longer than the accepted 2 or 3 million years, were supported by Webb's observations. But how can planets form if a disk doesn't remain around the star long enough for the pebbles to form and the dust grains to adhere to one another to form the planet's core? According to the researchers, planet-forming disks may continue to exist in environments deficient in heavier elements through to different mechanisms, or possibly a combination of them. The star first applies radiation pressure in order to blow away the disk. Elements heavier than hydrogen and helium would need to be present in the gas for this pressure to work. However, only around 10% of the heavier elements found in our Sun's chemical makeup are found in the massive star cluster in GC 346. Maybe a star in this cluster just takes longer to spread its disk. The second possibility is that a Sun-like star would need to begin from a larger cloud of gas in order to form, when there are few heavier elements. A larger disk will result from a larger gas cloud. Therefore, even if the radiation pressure were acting in the same manner, it would take longer to blow the disk away because it contains more mass. These discoveries might fundamentally change our knowledge of how planets form in the early universe and possibly provide fresh perspectives on the mechanisms that molded our solar system. Webb's revolutionary capabilities are anticipated to provide even more answers regarding the origins of planets and stars in the cosmos as scientists continue to investigate the early universe.